All right, everyone, we'll get started. So last week, whenever we went over routes, this week for lecture two, we're going to be going over databases. I'll start with some announcements. So for assignments, um, so the demos are very helpful for understanding the assignment. We had our first assignment due on Friday with the late deadline being up until tonight. Grades are going to be coming out on Tuesday. Normally, it's going to be on Sunday, with assignments being due on Wednesday. So demos are very helpful. You want to take advantage of them and rewatch the videos that we posted to YouTube as necessary. We have a test cases file that we send out on Ed Discussion. So that way you can see exactly what grade you'll be getting before you even submit it. Also, you want to make sure to save your Postman requests and collections and include that in your submissions. Towards the end of the lecture today, we'll be going over exactly how to do that in case some of you guys missed that the first week. Another thing is for the assignments, we also want you guys to write documentation. And so if you go back into the demo, you'll see I added documentation into all my routes, all my methods. And that just helps people know like what each route does. And the last thing is to follow the API specification exactly. And the reason why we say exactly is because in our test cases file, we're comparing against what we would want to see in the API specifications. So if you have something that's slightly off, it could cause our test case file to throw an error and say like this method did not return what we wanted it to return, and you get points off just because of some minimal issue or some discrepancy between what you actually returned and what the API specification wanted you to return. So yeah, just make sure to follow the API specification closely. Also, we have weekly feedback forms. They're linked on the course textbook. They're worth 5% of the final grade. Also, we have the Kahoot leaderboards that are always at the end of every lecture and demo. The first set or the first leaderboards was published, so that it takes into account the first week. And we'll be building on that each coming week. Does anyone have any questions about the announcements? Okay. With that, we're going to review over what we went over last week, just to make sure that we have a solid grasp on those concepts before we move forward. First, we went over the client-server model. So clients, as we know, are computers, like a phone, a laptop, a tablet, any mobile device. And the servers are also computers, but they're stationed somewhere else. It's like a desktop, but without a monitor. The clients will send the requests to the servers, and they'll be receiving a response. The client sends a request, gets a response. The server gets a request and gives a response. And so as remember, for requests, they're initiated by a client. So a client will send them. It's sent to a specific URL. For you guys on PA1, it would have been localhost with your port followed by a slash and then whatever the end of the route was. Common URL we'd all use every day is google.com/search. So the URL contains the domain, the route path, and the URL parameters, which is optional. If you guys remember, when we're trying to get like a specific task, we would put in the ID number into the URL. So that'd be a URL parameter. The domain is that first part, localhost and your port, and the route path is like the /tasks or the /comments part of your URL. You also have a method on each of your requests. The method refers to whether it's a get, post, or delete. And so that corresponds to that CRUD acronym that we went over during the first week. And then lastly, there's meaningful data that you'd send in the body of a request. And we use a JSON format. Also, if you guys are having trouble on Postman changing all your data from like the default into JSON, we're also going to go over how to change that for whenever you create a new request. So it just defaults to the JSON format because we're always using JSON in this course. Next, responses. So these are also still triggered by a client request. So the client's always triggering a request, and that request triggers a response. It returns confirmation that the request was operated on. And so this doesn't necessarily mean that it was successful. You could have an error in your response, but it just confirms that something happened, and it'll indicate what actually happened at that level. And so to go with that are the response codes. And so this indicates success at an abstract level. So, you know, all the 200 codes are for some type of success. 400 is some type of error, with very specific ones like 404 being not found. And so this sends back the JSON data in a body the same way it was sent from the client in a request. So if you remember, this is kind of what it looks like. This is like a visual example. We have the client and the server. Client sends a request. Request triggers data operations and returns a response. And then the server will send back that response to the client. Okay. So that was review from last week. Do we have any questions about how any of that works? Okay, next we'll go on to data persistence. And so this is kind of where we start building on what happened last week. If you guys remember, we started with a dictionary, which we called posts. And this posts was our way of storing what was our data. When we'd send data, we'd modify this dictionary. And this was kind of our equivalent of our data, our backend. But this isn't what we really want. There's many deficiencies here. And so one is every time you stop the server, like when you would Control or Command C and then reload your server, all that data would be lost and you'd be going back to your default dictionary. Also, it doesn't scale efficiently. A lot of our looping functions can be more efficient by having an actual database, and there's also no formatting enforcement. So when we move to what is actually used as a database on backend, there's the idea is that it's a collection of organized information. It's supposed to be easily accessible, easy to update, and easy to manage that data. And it's implemented as a collection of tables. So this is like a visual representation of what a database table could look like. As we see, each column has a descriptive name and a specific data type. Whoops. And the rows contain a set of column values, and each one represents an item. So the ID field is the unique identifiers that's required for every item in the table. As you remember from week 1, they cannot be repeated. The concept is the same. In databases, they get put there automatically and they're incremented automatically. So every time you create a new entry for your database or for your table, it'll automatically find what ID is next to use and put that in. IDs of removed items also do not get reused. So like in PA1, you're not supposed to be deleting or decrementing your post counter. And instead, you just keep incrementing that. That way you never end up with repeated IDs. So one thing to keep in mind is a database is not the same as a data table. Instead, a database is a collection of tables. So right here are 2 tables, which would both be in the same database. On the left, we have our users table, and on the right, we have our posts table. If we can see, our users have something like a name, an age, and a hobby, and maybe they each create posts which have a description and some number of likes. And so these tables go together to create what is our database. As always, we have our ID, which is the first field we always need. And then, as you can see, this table is much more neat than having a dictionary like we had previously. And so using these tables allow us to scale efficiently and have data in an organized manner. Okay, so yeah, the benefits. All the data is structured, it scales well, and you can query the data. So querying the data allows you to ask the database questions, and it's very helpful for large data sets where you don't need to write custom functions that interact with your dictionary. Instead, it's already built into the way we can query this database. And so one example of a query we might want to do is, let's say we have a table with our users and the users have an age, and we want to see which users are above the age of 20. And so this is previously what it would have looked like if we had done it in something like PA1, right? You have to iterate through in a for loop and then check a field and then do whatever operations you need. This is how it's done in an actual database. So you don't need to understand this just yet. We're going to go over how this works, but it's able to manage the data in your database much more efficiently than what we were doing in PA1. And so you do this using a structured query language. This is shortened to SQL. And that's what the language that you saw earlier, that little snippet of code. It's just as an overview. This language is for communicating with databases, and it allows you to execute, create, retrieve, update, and destroy operations through this language rather than what we had done previously in PA1. Okay. To this point, does anyone have any questions about the changes from PA1 to now what we're going to be using with SQL? Okay, I'll dive deep into SQL now. So first, there's ways to create a table. The way to do this is you have keywords, which we'll put in caps. So as you can see, create table are SQL keywords, and then you put in some table name, and then in parentheses, you have your columns with the data type. So it's important to note that when we're writing in SQL, we're always going to capitalize all our keywords. And this is how it used to be that you'd have to do this, and end up changing it where you could have the letters in lowercase. But a lot of times we keep the keywords uppercase just to separate that from the rest of the information, and it makes it more readable when you write some SQL. And so here's an example of creating a user table. As you can see, we have the name of the column as ID, and then we have the type on the right. So in this case, integer primary key auto increment. This will be used throughout because the ID is always going to be an integer, and it references our primary key, which just means like this is the main point we're going to look at for our key value, similar to how we did in the dictionary. And then auto increment is another keyword that just means it'll be auto incrementing so that we don't have to take care of that like we did in PA1 with +1 to the counter every time. Name, age are text non-null. It just means it can have any text field, and those values cannot be null. We don't want someone with no name getting entered into our database or someone with no age. And then an email is a set of characters up until the length of 50. And so as you can see, it's very organized. You have the name of the column on the left, and you have the type on the right. In order to insert data into the table, very similar structure. So you would write insert into, those are the keywords. Then you have the table name. Then you'd put the columns followed by the keyword values, and then whatever those actual values are. So an example of this could look like, okay. Also, first you can omit columns if you're inserting values into every single column. So usually you're going to be specifying certain columns. If you want to enter something into all your columns, then you can just put nothing there. You just put the table name, values, and the values afterwards. So this is what something could look like. Insert into user. So it's going to insert data into our user table, and into the columns name, age, and email, it's going to put John 21 and JS123 at cornell.edu. This is a much cleaner way of inserting data into our table, much better than iterating through a dictionary or trying to find certain pieces of information and then having it added in the form of a dictionary. This handles all of that for us. Next, I'll go over retrieving data. And so this is using the keyword select. You'd pick the columns that you want to retrieve, and then you'd use keyword from, followed by your table name. The asterisk, it gets used a lot, signifies everything, or selecting all the columns. So select asterisk from table name would get you the entire table, all the information available to you at that table. It's important to remember that a table is one element of a database. If you wanted all the data, you'd have to select asterisks from all your different tables. And so each of the tables represent a database, but the tables on their own are only a part of the full database. If you want to retrieve specific data, you can select and then put which columns you want to select from. You'd say from and then what table name. And then if you want to put a condition in there, you'd use the where keyword and then some type of condition. So if this was like age over 21, that's where you'd put it. And so in this case, select the asterisk here means select everyone from the users table, or select everything from the users table where the age is greater than 18. So anyone who has an age greater than 18, all those columns will get returned, and we're only looking in the specific users table. Okay. So I went through how to create a table, how to insert data, how to get data. Does anyone have any questions on that before we move on? Okay, I'll go on to updating the data. So again, the keyword to start off here is update. You'd put the table name, you'd use the keyword set where you actually want to set the values, and then at the end, the where keyword along with your condition. So here's another example applied to our users table. Update, the user is the name of the table. Set, that email equals is what you actually want to be setting. And then where indicates where we want to do that. So to interpret this, we can see that we're making an update to our users table. We're setting the email equal to jsmith@gmail.com, and the where indicates that it's at ID 1. So only that very first entry where the ID equals 1 will be changed, and it'll be changed that email to from whatever it was to this new email here. Lastly, we have deleting data. Takes the same, starts with a keyword again, delete, and then you don't need to specify columns because you're going to delete entries. So it's deleting from, and then you give the table name. And then you always want to put your condition when you want to delete, unless you want to delete the whole table, which you usually do not want to do. So delete from table name, where, and then you put the condition. For example, delete from user where ID equals 1. We just get rid of that specific user. Whoever's ID equals 1 gets deleted from our database or from our table and our database, I guess, through this syntax here. So that covers all the SQL code that we'll be using for PA2. I can go over anything that maybe I went over a little quickly. If you guys have any questions about specific update, deleting, retrieving questions, do you guys understand? Yeah. The order? Yeah. So, for the action, here, let's like
updating a table.
Wait, do you mean like do the order in which you like specify the columns matter?
I'll go to right here.
You selected a user table. Yeah. Can you have the where before the set? That's
what. So we follow this syntax because it's just like the convention. So you'd want to start with, yeah. So you can't have the order change. What you can have is in your where if you have multiple conditions. That's where like order wouldn't matter. But you have to start, the keywords are set. So you have to start in this case with update, the table name, set with what you want to set, where with the condition. If you did something else like deleting data, you'd have to start with delete from and then the table name. And then afterwards you put the where. And this helps us like maintain like a proper structure. Then when you're reading other SQL code, it all follows that same. You got the table name, you have what you're actually updating, and then followed by what the condition is. And there could be multiple conditions. That's a very good question, though. Anything else? Yeah.
So if you want to select a whole row from a database, you use that star symbol, right? And then you scroll. So specify like all the columns, right?
Let me pull up like a visual table here. Okay. So when you do select asterisk, the asterisk refers to selecting all the columns. So if you said select asterisks from this users table where ID equals 1, it would get you the ID, the name, the age, and the hobby. Yeah, so asterisk refers to the columns. The where condition refers to the rows or the entries. Good question. Yeah.
So say you delete an item like ID 2, it's still gonna be 1, 3.
Yeah, it'll go from 1. Well, actually, like, yeah, that row would just go from 1 to 3. Like this would just get completely taken out of our table. Yeah. And that 2 would not get reused as we went over before. We just don't risk reusing IDs because it could cause issues. We want everyone to be unique. Okay. If we have no other questions about this, I'll be posting this lecture online. We're gonna move on to going over some Postman stuff. We want to go over how to make a workspace, create a collection, and then export like a set of routes. So I'll have Joyce start sharing her screen and go over that.
I'm gonna switch. Okay, does everybody have Postman open? Just like to any page, like the home page is fine too. Okay, so just quickly going over some like pretty, I guess like neat things to help set your Postman up such that like you have a more like organized and like efficient way of like managing all of your like endpoints and the things that you're testing. We'll just be quickly I guess like demonstrating how to set up like a workspace as well as like collections on Postman. So essentially you can think of this as just like folders for all of your like requests and stuff. So for workspaces, it's up here in the upper tab. And as the UI suggests, you would just click create workspace and give it like a name. So I'll call it cool workspace for now. Okay, and then you can like change the visibility of it. You can share these workspaces with other people, supposing that you're working on a team. But for now, just make it personal. Okay, so once you've created a workspace, you might end up on a page that looks kind of like this. And here's where on this sidebar, this left sidebar where it says create a collection for your requests is essentially where you can create these collections to store a bunch of your requests. Again, you can kind of think of these as folders. So like, for example, it would be pretty helpful if you made a request or like a collection of requests for each of your assignments. So for PA1, PA2, PA3, etc. We do ask you to like export your Postman collection for every assignment. So this is like essentially where I guess you would do it. So just click this add button here to create a collection. And you see this is like a folder, right? Once you like drop down this folder, it'll tell you it's empty because we didn't add anything to it. And then we can just add a request to start working. Here we can also edit the name. So let's just say this is like PA1. So we called it PA1. And here is like a new request or any other request that you might want to test your program with. You can like go in here and like duplicate these requests so that like you don't have to retype the request URL every time you want to test another endpoint. And then to export this collection, you would hit these three dots and hit this export down here. And we just ask you to upload whatever this exports along with your like folder submission for every assignment. Does anyone have any questions on setting up this organization method? Okay. Oh, one last thing before I move on. In the case that like, so that from like last week, we know that we always want our like requests and our responses to be in like the JSON format. Postman does offer you like some other options as well, like HTML or something like that, to ensure that everything is consistent and is in JSON. What you can do is you can go up here into settings. So there's like this little gear bar. In the case you can't see, I'll like zoom into it. But it's just up on the top bar here. You hit settings, and then settings. And then there's this like language detection tab here, or like entry. If you haven't tampered with your Postman at all, it might be set to auto. So just go in and turn it into JSON to make everything easier for yourself. Cool. Okay. Any questions? All right. If not, we'll move on to like the SQLite3 demo. So if you go to the backend textbook here, for the pre-lecture to-dos for this specific lecture on databases, there's something to install SQLite3. SQLite3 is just going to be like the database that we'll be using for the majority of this course. It's a little bit like lighter. Well, I mean, it is called SQLite, but it's lighter in like a traditional database in the sense that like it doesn't really like run on big servers or anything. It actually like stores all of your data in a specific like file. But it helps with like smaller and lighter scale projects, which is the reason why we're going to be using it for this course. If you haven't installed SQL3 yet, you can go install it now. There's some like links here. If you're on like a Windows machine, if you're on a Mac machine and you happen to have Homebrew, you can also just install SQLite3 in your terminal, and that should get it installed as well. Is there anyone that, oh yeah. Oh no, so it's not like a requirement or like a dependency that you install into your virtual environment. It's just like a, I guess, like separate program in and of itself. So, well, I mean, because today we're just using it in the shell, but when you actually do your assignments, it'll be in like the requirements.txt. Does anyone like want some time to install SQLite3, or is everybody okay? Okay. Yeah, so this will also be posted on the YouTube, of course. So if you don't necessarily have SQLite3 right now, you can follow along a little bit later on the YouTube channel. Okay. So to start the SQLite3 shell, we just type in SQLite3. And this should like give you some notification stuff. And once you see that the terminal here has changed to SQLite, you know the shell is properly working and you can like manipulate with like databases and stuff. Okay. So first, let's create a table, right? As Matteo was talking about earlier when he was going through the SQL commands, the command to create a table is create table, and then we'll give the table a name, so user. With SQLite3, we can make multi-line queries. So you know that like once you end your query with a semicolon, it'll know to like stop it. But we can create multi-line queries here to make things easier to see. So we create table user. First, it needs an ID, right? As Matteo mentioned earlier, usually we have integer primary key, auto increment. So we know that this ID is the primary key for this table, and it'll automatically increment itself every time we add something new into this table. Then let's create a column. So for people's names, so text not null. We enforce the condition that this specific column can't have a null value in it, which means that essentially like the database won't let you enter something even into this database if this field is null. Oh, I don't know if I needed a comma here, but okay, we'll see. And then, so let's say this is like a table for people's favorite boba and stuff. So let's just add like the other columns in, favorite boba, char20 not null. This essentially means that we enforce that for this specific column, we need only like a maximum of like 20 characters in any entry for this column. And then favorite topping is text. And that's just going to be like a string in SQLite3. I probably needed a comma there. Yeah, okay. Okay, so now our table is created. Does anyone have any questions on the creation of a table? Yeah, just a note, to separate the columns and like their qualities, you do need the comma, which is why I couldn't create it in the first time I typed it in. Okay, so now if we want to see all of the tables that we have in the database, remember as Matteo mentioned earlier, the database isn't a single table, but a collection of tables that you have. So if we want to see all the tables that exist right now in our database, which is just the user table, we type .tables. And we see that, you know, the only table that we have in our database is user. Okay. So now let's actually put values into our table. So as Matteo also mentioned earlier, the SQL keyword for that is insert into your table name all of the things you want to insert into a particular column, and then the values that you want to insert into that particular column. So let's like, for example, add myself into this database. So we do insert into user, which is again our table. In the name column, the favorite boba column, and then the favorite topping column. These particular values, right? So we specify the values, let's say Joyce, winter melon tea, and then boba. Wow. Did I type it wrong? Okay. So here we've inserted myself into the table. Let's see if we're actually in the table, right? So as Mateo mentioned earlier, if we want to see if like all the columns in the table, we'll do select star from the table name, which is user. So you see that I'm there. My favorite tea is like wintermelon tea, and I like boba on it. Yeah. So let's insert some more people in. So let's say we also want to insert Mateo in. What's your favorite boba, Mateo?
Generic milk tea.
Just milk tea? Okay. Oh, okay. Oh, wait. You can also terminal command up to just replace or go to a previous command that you use, so you don't have to retype it like I just did. Okay. So now Mateo is also in our database. Let's check it out by doing select star from user. Oh, oh, okay. Oh yeah. So from is also like a SQL keyword. So for SQLite3, you can like actually just type everything in lowercase and it'll like recognize all of the keywords for you. But just like more traditional SQL syntax is that you want to like capitalize all of the keywords, and from is also a keyword. So you should like capitalize that as well. Oh yeah. Wait, how do I move like the oh, okay. Okay. So yeah, let's add some more people in there. Oh, paste. Shunga, what's your favorite milk tea?
Mine,
Yeah.
lemon yakult,
What's your favorite topping?
jelly.
Okay. Okay, so now we have 3 people in our database, as you can see, with a select star from user. All right. So what if like we try to so let's tamper with some of the other sort of like qualities that was mentioned like a little earlier, right? So we knew that like some of them can't be null. So what if we try to, you know, insert like a null value into something that actually can't be null? So something with SQLite or just like SQL in general is that you can also only insert into like certain columns. So you can specify the columns that you want to insert into. And for example, if I didn't actually insert into a column that, you know, should have not been null, then SQL will like get angry at me. But let's just try like selectively inserting something. So instead of name, favorite, boba, and topping, let's say I only try to insert a name, right? And let's do like page. So now SQLite3 is a little bit angry at me because it's telling me that like I failed this not null constraint on favorite boba, which is problematic. So let's try again. Kate, what's your favorite boba?
Just like milk green tea.
Okay, green milk tea. So now SQLite3 is okay with this because we made all of the not null fields have something. But remember up here when we made the table, the favorite topping field, right, was only text. It wasn't constrained that it had to be not null. So it's fine if like Kate doesn't have a favorite topping for her boba. Okay, does anyone have any questions on like the insertion part of this database operations? Okay. If not, I guess we can also work. Let's just take a quick look at actually like querying the data. So you see me already press like select star from user a lot. Again, the star just indicates that we want to retrieve the values in every single column, but we don't actually have to do that. In the presentation a little earlier, you might have seen Mateo talk about specifying the columns that we want. So let's say we don't care about anyone's actual favorite boba, and we only care about their names. So then we can just select name from user. And that'll just spit out everybody's names and nobody's favorite bobas or toppings or anything like that. And we can do this for like multiple as well. So select name favorite boba from user. This will give us everybody's name and their favorite boba, but nothing else. And then finally, we can even give it like a condition to work off of, right? So what if like I only care about the people whose favorite toppings is like jelly, right? So I can select name. Let's say I just want to return their name, right? So select name from user where favorite topping equals jelly. And as you remember before, Shungo was the only one out of us that said his favorite topping was jelly. So SQLite3 returns as Shungo. Any questions here on the querying part of the data? Okay, if there are no questions, next is just going to be actually like updating the data. So let's say that like we want to like make some changes into our database. So let's say that like, for example, I suddenly decide to like become a menace and I don't actually want boba in my drink. That's not my favorite topping anymore. I actually want cereal in there. So what we do is we use the update keyword, update user, set favorite topping equals cereal, where, and if you remember, I was like the first one that I added into the database. So my ID should, like by logic of like the primary key that auto increments should be number 1, right? And where is also a keyword, so traditional syntax asks you to capitalize it, where ID equals 1. So now let's look at what's in the table. We'll do again, select star from user. And now it seems that, you know, my favorite topping is like cereal, while everybody else is something regular or nothing at all. Yeah, and you can also do this for, again, you can also like set, I guess like a condition for this if you want to only update, you know, things for like specific people. For example, you know, people are like, yo, why she like cereal? That's like really, really weird. And we only want to like update, you know, I guess like the favorite drink of the person that likes cereal, which is me. Then you would do update user, let's say set favorite boba equals, or you can change this to like Earl Grey milk tea, where, oh, I guess I already went over like the where, but anyways, you can do this for like other columns as well. Favorite topping equals cereal. And this will once again change it. Yeah, and note that you can also like use commas here to separate out multiple like columns that you might want to change. Let's just do another example real quick. So I'll do like so favorite boba is winter melon. It's like name is weirdo. And if we select again from user, we can change multiple columns there as well. So it's not Joyce anymore, it's weirdo. So I'm not a menace anymore. Okay, make sure to capitalize from. I'm sorry, I keep on capitalizing my froms, but yes. Okay, and then finally, oh, does anyone have any questions on updating values? Okay. If not, then the last thing that you might want to ever do, or like the basic operations in a database would be to like delete values, right? So let's say we want to delete this like weird person who likes cereal as their favorite topping. So you would delete from user where favorite topping equals cereal. And if we once again check our database, we see that the first person who somehow likes cereal in their drink is now gone. And then finally, if we want to say like delete everyone in the database, then the command here would be like drop table user. And then if we just do the tables command again to see all of the tables that we have in the database, you'll see it's not there anymore. In the case that like you have multiple tables in your database and you only want to drop some like particular table that like exists, and you're like kind of scared that SQLite might throw you an error that like you're dropping a table doesn't actually exist, you can also add a condition to this drop command, and write like drop table if exists user. So this would hypothetically only drop it if the table exists, but the table doesn't exist now, so we're all good. Does anyone have any questions on the deletion of an entry in the database or like deleting tables in a database? Yeah.
What happens if you drop table?
If you drop a table that doesn't exist, I believe it'll throw you an error, like drop table high. It'll tell you that there's no such table as high. Any other questions? Okay, and then finally, if you want to just exit your shell, just .exit and it'll get out of your shell. Okay, so yeah, that's it for demo. Any questions on anything that we kind of went through here? Okay, if not, we'll be moving into the Kahoot for today. And yes, just a disclaimer, yes, be sure to capitalize your keywords. Not the best of practice for me to not capitalize them, but yes, bad habit from databases.